Have you ever heard the statement that only Chuck Norris can divide by 0? Well, it's true. No. But what we do want to make sure is anytime you have any kind of a fraction and a rational expression, which a rational equation is just an equation that contains rational expressions, also cannot have 0 in the denominator. No 0 in the denominator of a fraction. That is basically the rule. So sometimes in this case, if t would be 0, then we would have 0 in the denominator of our fraction, and we would not be Chuck Norris, so that can't happen. So the first thing we always want to do is we want to remind ourselves to restrict values for our variable that would give us 0 in the denominator. And for this problem, t better not be equal to 0. And I say t can't be equal to 0, and I'm going to put that in a puffy cloud to remind myself that if I work this problem and I get t equals 0 down here, I'll say no, that can't happen. No solution. All right? Now, again, what we're going to first of all do is clear out the fractions by multiplying everything in our problem through by the least common denominator. Basically, what quantity is going to cancel out a denominator of 3 and a denominator of 3t? Well, we need a t. And a denominator of t. Well, we've already got the t. So 3t is going to do it for us. So recall what we do to clear out our fractions is we multiply both sides, or each term, by 3t. I'm going to write that over here. Now comes the fun part. We get to start wiping out those common factors. And so here, first, the 3's reduce, leaving us with just t times 1, or t for the first term. Here, the whole shebang of 3t reduces, just leaving us with minus 4, equals, here the t's reduce, leaving us with 21. Now to solve the resulting equation, when we add 4 to both sides, we get t is equal to 21 plus 4 is 25. So this is an example of solving a simple rational equation. We got t is equal to 25. That's legit because it's not 0. Whereas on our next example, this is another, oh, is that the next example? Yeah, there's the next example. This is another rational equation, but this time slightly different. Our value that we need to restrict that would give us d in the denominator, or 0 in the denominator, is not 0. 0's okay here for d, but d can't be equal to positive 7. That would be a problem. If d was equal to 7, then in each of these denominators, 7 minus 7 would be 0. So remind yourself here, and then we are going to find the least common denominator. And when we're considering canceling out d minus 7, you need to know that is a package deal. That comes all together. So we need a factor of quantity d minus 7 to cancel out each of the d minus 7's there and there. And we also need a factor of 8. So you can either say times 8 on the end here, but I think it looks prettier to write the 8 out front. That just makes me feel a little bit more comfortable. All right, now what we're going to do is we're going to come along here and multiply each of these 3 terms by that least common denominator. So here I'm going to multiply times 8 times d minus 7 there, times 8 times d minus 7 there, and here as well. Okay, you ready for the fun part? That is wiping out those common factors in the numerator and the denominator. D minus 7, that whole shebang, reduces with d minus 7, just leaving us with 7 times 8, which is 56. Here, we can only reduce the 8, and so we have a negative 7 times the quantity d minus 7. If you want to go ahead and run that through, you can. I'm just going to bring negative 7 times the quantity d minus 7 down, and I'll run the negative 7 through. I don't want to make any mistakes with that being a negative there. Okay? Now here for the term on the right-hand side, when we reduce the d minus 7 with this d minus 7, we are left with d times 8, also known as 8d. All right, now let's do our algebra and let's solve this equation. So here we have 56 minus 7d. Oh, I can do better. Hold on. 7d okay, 7d plus, because a negative 7 times a negative 7 is going to give us a positive 49. 8d. Why can I not write d's? There we go. All right, now I'm going to combine the 56 and the 49. I'm going to do that in just a 7, but let me go ahead and sneaky that. Add 7d to both sides. Why not? Okay. 56 plus 49, oh goodness, will give us 9105. 8d and 7d combine to give us 15d. Solving for d, divide both sides by 15. And 105 divided by 15 comes out to be 7. 7 equals d. Now, if you go along here and you tell the whole world, hey, my solution set is 7, that means you should be able to check a 7 back up into your original problem. But what did 7 do for you? It gave you 0 in the denominator. That, in the puffy cloud above, is restricted. So you know what happens here? Our answer is not 7. Our answer is actually no solution. Because that value of 7 we got, like from legit math right here, that value of 7 we got would give us 0 in the denominator. So our answer is not 7. It's no solution or the empty set.